Okay guys, in today's lesson we're going to be talking about factoring trinomials where a is not equal to 1. The things that we've been doing for the past 2 days have the coefficient on a as 1, and so we're able to just break this into 2 parentheses and factor it by saying what are the multiples or the factors of 4 that are 3 away from each other, and that would have to be 4 and 1. And in this case 3 is negative, so we would make this -4, +1. If it was set equal to 0, then a would equal 4. Or a would equal -1. What we're going to look at today is an instance where the a value is not 1. So if it's 3, if it's 2, if it's 2 over here. And what we're going to do is use this x method. So when you're looking at this x, in this box right here, in this little section right here, you're going to put the value of a times c. And in this little section right here, you're going to put the value of b. Then we're going to work with these 2 little sections to figure out how to factor this. So if you look at example 1, the a value is 3, the c value is -5, 3 times -5 is -15. The b value that I'm trying to get to is -2. Okay? Now, I need to still figure out what are the factors of 15 that are 2 away from each other. So 15 has factors of 1 and 15. That won't work, but you can also use 5 and 3. You want to make this equal -15 if you multiplied and -2 if you added. The only way to make -2 is if this was -5 and that was +3. That would add together to give you +2 or -2, and it would multiply together to give you -15. So this is what you're trying to add to, this is what you're trying to multiply to. The next thing we're going to do is take this -2p, and we're just going to rewrite it as negative, let's use +3p and -5p, right? Because this still equals -2p. Then you're going to bring down the -5 from here and the 3p squared from here. These 2 numbers, 3 and -5, are coming from right here. If you're wondering why I switched them, pay attention to the next step. We're going to group the first 2 terms and the second 2 terms. What is a common factor that comes out of 3p squared and 3p? The common factor is 3p. When you divide 3p squared by 3p, the answer is just p, and then plus 1. Looking at the next set of numbers, the common factor is 5. You want these to have common factors here and common factors here. That's why I had to switch. Originally I was going to put the 5 here and the 3 here, but 5 and 3 would not have factored, and then 3 and 5 would not have factored. But if I look at it this way, I can factor out -5 from the second set and be left with p plus 1. Now, this is what you want to happen every single time. Something in the parentheses has to match up and has to be the same. So one of the factors is, very simply, p plus 1. The other factor is what's left over. So what's left over outside these parentheses is 3p and then -5 equals 0. You're still setting it equal to 0, so in this case p would equal -1. Most of the time when we do these, you're going to get a fractional answer. So 3p minus 5 equals 0. You're going to add 5 to both sides. That equals 3p. You're then going to divide by 3 and leave it as a fraction. P equals 5/3. Okay? So I'll do the next few with you. Look at number 2. You're going to multiply 2 times 21. You're going to take the middle term and put it there. You're looking for factors of 42 that could somehow give you 17. Okay, so on the side, 42 is 6 and 7. That's the most common one that people think of. You also have 2 and 21. Neither of these will give you 17 if you added them or subtracted them. So if we did 42 divided by 3, that would give us 14. 3 and 14 will make 17. So 3 here, 14 here. Keep the first term, keep the last term. Rewrite 17 as +3 and +14. From the first two terms, you can only factor out an x. From this term, they have a common factor of 7, positive 7. Our parentheses match up, so that's one factor. The other factor is what's left over. Here, x would equal negative 7. Here, 2x plus 3 equals 0. Take away 3, so 2x would equal negative 3, and x would equal negative 3 over 2. Next case, 2 times 7, middle term. Factors of 14 that could somehow get you 15. It has to be 1 and 14. Rewrite 15. First, let me bring this down. Rewrite 15 as positive 1 and positive 14. There's nothing you can factor out of here except for an n. You can factor out of here a positive 2. Here's what factor that matches up. So one factor is 2n plus 1. The other factor is n plus 2. And this all equals 0. Here, n equals negative 2. Here, n would equal negative 1/2. Now, this works technically for the case where the coefficient is 1. However, I would have just taken this and factored it right away. If you're looking at this, though you're looking for negative 27, that adds up or subtracts to give you 6. So if you like this x method, you can use it when the coefficient is 1. It's just going to take a little bit longer. The product, or the factors of 27 that would give you 6 would have to be positive 9 and negative 3. You're rewriting positive 6 as positive 9 minus 3. Group this together, group this together. Common factor is m. Common factor is negative 3. One of the factors is m plus 9. The other factor is m minus 3. But remember, if you recognize that the coefficient is 1, just start from here. Whoops. Go right away and just factor into m, and then 9 and 3, positive, negative, m equals negative 9, m equals 3. I'm going to do the last one by just factoring it like we've been doing it, with just the parentheses right away. This has to be 5 and 2. They both have to be positive to give me 7, positive to give me positive 10. T would equal negative 5. T would also equal negative 2. Okay? What you're going to do now is do the back. There are 4 questions on the back. 2 of them have coefficients of 1. 2 of them you can use this X method. When you're done with this, show this to me so I can give you guys credit for taking these notes, and then I'm going to give you a very short, I think it's like a 6-question worksheet.